Hey, your friendly DevOps admin David from Trivial Solutions IO here. In previous video I speak about ZFS, but of course file systems have to reside in some operating system. So today we'll talk about operating systems and my favorite operating system, which I run on my laptop, and also I prefer to run it on my servers if I can. If I can't run that, then I run other Plan B operating system, one of the mainstream ones. So let's talk again. This will not be like a tutorial how to install it, blah blah blah. These things can be figured out, right? The internet is full of tutorials about everything these days. But I want to talk again about why, the philosophy of why we do what we do. So the goal, the highest level goal is always, run infrastructure cheaply and efficiently. That's the high level goal. Anything that we do should help to achieve that goal. So philosophy, for me, philosophy is, from my experiences anyway, operating system is a tool, not a product. It will never be a product. So if you visit Facebook or you visit Google or you visit YouTube or any platform, you don't care what operating system is underneath, right? Nobody cares. It's like the silent hero. Some may be more efficient, some may be less efficient. They have different properties, but users don't care. They don't help directly contribute to good software, right? So I want to talk about, when picking operating system, what do I want it to do so that we could run it cheaply and efficiently. So what do we want? We want it to be low maintenance. We don't want to babysit it. We don't want to put it a lot of attention so it would work. Ideally, it would be our friend, just help us get things done and not get in our way, right? Another thing I like is revertibility. Again, I mentioned this in like high level goals, that after doing changes, I'd like to revert. Just in case if something bad happens, I want to know that just like in Git, I can always get back to the previous state and forget that something bad happened, right? The third one is, let's run stuff and don't get in the way. It should allow us to, use the computer, use the resources, but don't get in the way. Like we shouldn't be swearing every time, oh, I want to deploy another application, I want to deploy another container. Oh, I'm gonna have to do this, a lot of juggling to do that. We don't want that. It should be easy to run stuff. An operating system, we should forget it even exists, right? So another thing I want is long life of a machine. I don't like, in a lot of companies, it's just, it's like typical, this machine is busted. It got like a provision with too much bad stuff. Now it doesn't work. Just reinstall it from scratch. Oh, you don't need a server? Just reinstall it from scratch. Just reinstall it. Why do we do that? Like, why can't we just have one machine, install it once, possibly upgrade things just like Linux kernel, and then live our lives happily ever after? Why can't we do that? Why is it that, machine gets so screwed that we need to reinstall it from time to time? So ideally, I would like to avoid this, right? So what is my strategy of doing that? I typically install on my machines very minimal packages, just ZFS that we talked about, great file system, Docker, so we can run any containers, and Nomad and its friends like Console, Vault for secrets, so that we can schedule containers and just run them and see like an overview of infrastructure in one place, right? So I install like a very base layer, everything, just get Docker containers working, right? So, and then once you get Docker containers up and running, then you can run anything you want, right? You can have like a Debian operating system, but you can run inside a container CentOS, or you can run Alpine Linux, or you can run like another Debian, different versions, and you don't care. You know that you will not affect machine state negatively, no matter what Docker image you use. Well, there are some exceptions, like for instance, Elasticsearch needs like setting the m.max map count or something to set so that container would run. Anyway, it's a detail, but mostly running any container should not affect the state of a machine. And then if you want to migrate container to run on another machine, you can do that. You stop the container on previous machine. If it has like a state, you might want to back it up, send it to another machine. When you delete the state, you know exactly the files that were running there. Docker container doesn't have any files. Hopefully you don't bind root to it, but generally Docker container only accesses what you give it. So you give Docker container like one ZFS data set, then you bind it, run it, right? You delete that container, you delete ZFS dataset, and your machine is again as if it didn't run anything. And Docker containers are very lightweight. They're run in the same kernel space, so it's very lightweight virtualization. So, and our machine becomes just like resource, right? It has certain CPU, it has certain RAM, and it has disk space with ZFS, and we just can use it anything you want. You delete a container, you can raise up other container with other data set, and your machine can live a really long time with that. You only need to do kernel upgrades from time to time. All right. So yeah, I already talked about, basically we reached the state where adding, removing containers, we don't affect state of the machine. And I can't repeat this enough. We want the same machine to just serve us long time and keep on running. Right, so candidates, my favorite operating system of all time, Linux operating system, is NixOS. So ideally, if you can run it, NixOS, on your machines, you should do that. And what's so great about this? This is like a lot of these are like Docker containers, but they apply to the base level, to the operating system as well. So revertible upgrades. So like if you install latest kernel with NixOS, you can get back to the previous state if you want pretty easily, right? So you edit a configuration file, or you can use NixOps to provision configuration file, but you edit configuration file, you rebuild the operating system, you might reboot and see if everything is working. And if stuff is not working, you edit the configuration file the same way it was, or you can just set previous version to run, and then you can rebuild system. And the way you edit, like your entire operating system becomes a text configuration file. So if you edit configuration file, you rebuild, then that will be the same machine that you have once you have configuration file. It's like Git for your entire operating system, all the packages, everything, right? So it's the only Linux distribution that has this. Well, GUIX has this, but GUIX is a fork of Nix, so I think it's the same thing essentially. But this is the unique operating system in Linux. I should definitely check this out. And also NixOS has latest software. So if you use like older Linux distributions like CentOS or Debian, you see that a lot of the times you might want the latest software, but it's just not there, right? You just have a lot versions lower of the software than you would like to have. So then you have to add package repositories to get the latest software. In Nix, you can just have the latest software. And not even that, you can have multiple versions of software. That is mentioned somewhere here. You don't have version conflicts. So like you can you can even take the Git hash of the entire repository and just have that package from that version of the Git. Well, the operating system may be completely something else, but you can have a different version if you want. No problem, you can have all the versions you want. But usually you can just use latest software and you will have latest commit, latest builds, and that's how you roll in NixOS. So another thing is NixOS has reproducible builds. And well, Docker is close to that, but Docker has issues. Docker has, like, you have a Docker file and then you run and change the state of the container, and it might fetch packages from the internet, right? It then might bind to those certain packages. Those repositories might not exist. You might not reproduce the same build like 1 year from now after you build a container. And this happened for me quite a few times where I just, I had some old software and it was working fine for a year or two, and then I need to get back to it, and I figure I can't rebuild the same Docker container because it just depends on internet resources that change over time, right? So NixOS, everything is reproducible, and when you're building, you don't have access to the internet, right? So what you bring into the build can only ever be deterministic, right? There are, of course, exceptions to that, impure like builds or something, but in general, everything is versioned and everything is reproducible, and you always know which version of what you have. It's not mystic. It's not like you just go into operating system, you set up custom package, custom version, you hacked something like systemd unit, you hacked it by hand and it doesn't appear. Everything in NixOS is reproducible, right? So it's completely different from other mainstream Linux operating systems. And installing new packages, you don't affect state of the machine. So like imagine, like in the old school way, if you're just using like typical Debian and you log into the machine and you want to install like a Postgres latest version or something just to test something, like tell to admin, oh, I will go into this production machine and I'll install, Postgres version I'm running, and they will say you're out of your mind. Get out of here. What you're doing, And in NixOS, since you just adding new packages just takes up disk space, that's the only side effect, but it doesn't break anything existing that's working. It might rebuild packages few times, different versions, right? There might be some duplication, but you don't affect existing stuff that's working. So you can say, if you need like some Postgres command line, you write nix -shell -p and PostgreSQL, and boom, you have Postgres command line tool, and then you can connect to instances. And you have a lot more confidence that things will just work, right? So it's like I could explain a little how it works, but yeah, actually I'll do that. Okay, so how NixOS works, so say you have like package version A, and package B depends on version A, say in some library or something, and you can build in NixOS just, okay, say this is your base operating system version, A depends on B, right? But there's a lot of this issue, like if you have Debian and say, okay, I want new version of B, and you say, okay, I want version B, like 2, and this is newer version, and it depends on newer version of A. So what typically happens in like Debian, I call this like the screen of choice of death. Basically, package manager offers you, okay, we have conflict. Do you want to upgrade A as well, right? But it would do like, it would kill this version of A, remove it from the system, and there might be like, C or E depends on A, Now we don't know if these two will work, right? We might break something. Things might explode, right? But in NixOS, what just happens is, okay, B depends on newer version of A, and NixOS will just build another version of A, and they don't have any conflict. Everything's hashed, like builds have their unique hash IDs, and all these packages can just coexist in one Nix store. And if you don't use it, you might get some garbage. You run Nix collect garbage and all that space is reclaimed. But in NixOS, things will just work, because if certain package depends on certain version, it always gets that version and it will always work, right? So it's not like Debian, okay, we upgrade B, now we have to remove this package, possibly update newer version. These depend on that, and then it could end in disaster. And then, of course, how do you roll back if something screws up? So, like, this is like completely different than when you need to mutate packages. So I really recommend NixOS if you can. I run it on my laptop. I read it on my custom infrastructure services. Not too mainstream at this point, but if you can do it, NixOS is a great choice. And if you can't do NixOS, right, a lot of people are old school. Debian also stood a test of time, right? I don't see much difference between things like CentOS or what is it, Alma or Rocky Linux. I don't care. For me, all the other distributions that are like Debian or CentOS are very the same for me, right? They have the same issues that, they usually have old software. You can't solidly upgrade stuff, right? But we can run Docker infrastructure also of these, but you have to be really careful. And I'll repeat this again, what I said here. Install only minimal packages that allow you to run Docker in ZFS. That's it. Like I add Docker repository because on Debian, the latest build, that's better from Docker directly, Docker repository, not the original one, and OpenZFS repository. And then you install those, get to the state where you can run Docker containers in OMAN. And I typically also install like really OG packages, old ones that come with Debian that will not corrupt machine, like Telnet, IFTOP, and a lot of other tools, HTOP, that are like old packages, but they're just admin stuff, so you can view like, what is I/O usage, what is disk I/O, what is network bandwidth usage on a machine. I don't add other repositories beyond that. The most important thing is that we run Docker and we're good, and our machine should live a long, happy life, right? So that's how I roll with the operating systems. This has been David from trivialsolutions.io, and I'll see you in the next videos. Bye.